Okay, this second part of the second part of a QMP or a PQP should actually comprise of a quality assurance. This particular concept of quality assurance. In TQM, we have got, TQM, like I said, is a concept of a QMP. So when you design a QMP, you can take it, as that. Maybe I do not want to use the word TQM here, it may be confusing. So I will change it to QMP. Yeah? So or QMS, okay, a quality management system. So a QMS or QM system, it will have what we call a QA phase, you see. And what is a QA phase? It is not about ISO. It is not about just documentation. It's not about getting a certification from some international company or international flags, that says that you are quality assured in that sense. It doesn't make sense. If you think about it logically, does it make sense? Just because of you've got you went to get an ISO, does that mean that your products or services or your activities in your organization are actually quality assured? It makes sense that way, you see. So the concept of quality assurance is about putting in a system that allows you to actually check, to allow you to actually inspect, audit, and to look at the product, test the product. It's a combination of all this. It's like these activities help to ensure that the final product, activities, and services that comes out from your work, is actually delivered according to certain requirement. So you see, QP actually tells us to put down all the requirements. You see, it puts down all the requirements. What are the desired level of quality? What is the purpose of doing that? Doing a specific system, or what is the purpose of having certain acceptance limit or acceptance criteria, plus or minus something, because you need to understand that it's better to motivate people to do it rather than you just make people scared and fear of punishment to do it, you see. So you want contractors to understand that when they do concrete cover, it has to be 25 plus or minus 5 mm, for example. Why? So they need to understand why, so that they will voluntarily do it, because they understand if they don't do it later on, it may be issues with maintenance, it may be issues with product not looking aesthetically good, or it may reduce the strength and affect the other parts of the structure, for example. If they understand it, then they will be more willing wanting to do it, you see. So in planning, we plan all the requirements. We plan all what are the acceptance criteria, what are the metrics, what are the rubrics, When we are planning that, we are also planning our devices, which is our maybe machines, equipments, and also system to check, a system to actually make an effort to carry out certain, it's like attempts or efforts. Okay, I won't say attempts, it will be efforts. Make sure that, you collect enough data to do two things. One, if there is a variance, is you are able to detect that variance. That is very important. And if you do have variances, why did it happen? So it only can come from when you have sufficient data. If you do not have sufficient data, it is impossible to check what are the root causes of the problem. So, you see, in this interim, even though this word is quality assurance, it may sound like a product. It may sound like a branding. Let's say when we buy Nike, when we buy Toyota, when we buy iPhone, we tend to see it as quality assured products, you see. So quality assurance has become associated with some form of branding. And that is not true, you see. I mean, it is the final result of quality assurance that you have a good product, and this good product will get into the market. This reputation of the company will get into the market, and people will see that you are a good project manager, or the product that your company builds are usually very good. Like if let's say there's some developers over the years, over 20 years, over 10, 20 years, they build very good quality houses. So when their name come up in the market, they become quality assured, you see. That kind of assurance and what we're talking about here is actually two different things. Here is about having processes, intact. This is an interim phase that you need to plan all the procedures, internal or external, that you need to ensure that the product will meet that desired level of excellence, you see. So it will include plans to monitor. How do you monitor? How do you collect data to monitor? How do you analyze those data? And then from that data, how do you detect the variances? How do you detect when there's a variances? How do you make improvement to the processes? And how do you make sure that, we can prevent certain things, certain mishaps, or certain mistakes from happening? So it is not just prevention. It is just not when it happens what to do. It's combination. It's actually multifunctional. It includes doing monitoring, what to monitor, how to monitor, what sort of tests that you want to put in place, what sort of devices to check, what sort of devices to use to monitor. Is it calibrated? Is there a specific method or steps that you need in order to monitor and check? And then, like for example, concrete, we will say to do the fluidity of the concrete, to do the flow, then you need to make sure that it flows, it's a ready mix. So that flow must be just nice. It cannot be too thick, it cannot be too thin, see? So if too thin, then the aggregates and the water part will segregate, and it will end up to be too layered. There'll be some layering in the concrete at the end of it. But if it's too thick, it doesn't flow, you see? So the fluidity is not there, you see? So it's not healthy that way. I mean, it's not exactly healthy like this with it, but it's just not good for working in that sense. So what we do is we need to say, okay, to make sure that the desired quality of the structure is part of it is concrete, correct? In concrete, what do you need to do? You need to maybe get few areas like the workflow, like how do you mix it? How do you design the mix, and then from the mix you put it on the truck, and then when the truck do it, come to the site, what is the steps of making sure that, you pump the concrete in time? Is there any time limit to it? And when you pump it out, do you need to do quick tests? So you add in quick tests, you add in slump tests, and you add in why these types of tests are done. And then you also need to put in the certification, the mix, the mix formulation for approvals. So when you request for this, and then you put it in your P2P, all these items that you have to ensure you how to monitor, and then how to collect data, and how many specimens to collect, and then how long the result must come up. And when you see the results, what is the actions to be taken? Then we have the actions to be taken. If there is a variation, if it's not something that is not good, what do you do about it? So quality assurance is really a whole process or a system that you are putting in place, to measure, to safeguard, to ensure, to test, to experiment, to make sure that it will apply. So this is different from, this is actually not quality control yet. This is only to put all this in a system. It's there, then it is quality assurance. Then when we actually monitor QM, and also when you control, then that will be actually quality control.